Hello students, my name is Ajita. I am working as an assistant professor in the Department of Computer Science and Engineering at St. Joseph Institute of Technology. So in today's class, I am going to take singly linked list. So before going into the concept, we should know what is singly linked list, what is data structure, what are all the types of data structure. So what is a data structure? A data structure is a specialized format for organizing, storing, processing and retrieving the data which is present in the computer's memory. So what are all the types of data structure? There are of two types. One is linear data structure and the other one is non-linear data structure. A linear data structure is a data structure in which the elements are stored sequentially or linearly, where each element can be accessed either through the previous or next node. So the examples of linear data structures are array, stack, queue, linked list. So a non-linear data structure where the elements are not stored linearly or sequentially, which cannot be accessed easily through the previous or the next node. So the example of non-linear data structure are tree and graph. So next we see what is a linked list and how the node is created using the node structure. Before going into linked list, we should know what is a node and how to create the structure for the node. A node will be having two parts. One is the data part, the other one is the next part. The data part is where the actual data is stored. And the next part stores the address of next node's memory address location. So this can be converted into a structure. So let me write the structure of the node. So structure should be written with the struct keyword. So struct, the name of the node is node. So the name of the structure is given as node. The first part is the data part. So data is where the actual data is stored. So the data can be of integer, it can be of character, it can be double, it can be float, it can be of any data type. So for our example, I am taking the data to be an integer data. So int data. And the next part is it will store the address of next node's memory address location. So this will be a pointer variable. For this struct node, I am going to create a pointer variable for next node. Struct node, pointer next. Since it is going to store the address, I am using the pointer variable. So struct should be ended with a semicolon. So this is the structure of the node. For this structure, I have written the structure of the node. So initially, before creating a linked list, there will be no node that is created. So you will be having a start pointer which is pointing to null value. So let me create the start pointer for the struct node. Struct node, pointer start, because the start is also going to point to an address. So I am using the start. So which is equal to null. The start is actually point to the address of the first node in your linked list, but initially, since there is no linked list, your start will be pointing to null value. Next we see the types of linked list. So there are basically three types of linked list. First one is singly linked list. Second one, doubly linked list. And third one is circular linked list. So in today's class, we'll briefly learn about what is singly linked list. So singly linked list is a special data structure or a linked list which has a link to only one node which points to the next node of your link. So we have basic operations. First is insertion. So insertion can be performed either at the beginning, at the specified position, or at the end of your linked list. Same as that, you have deletion. So deletion can also be performed at the beginning, at the end, or at the specified position. Third one is traversing. Traversing is a process of visiting each and every node exactly once so that you can print or you can traverse through your data. And the fourth operation of your linked list is search operation. So if you want to search any element of your linked list, you can use this search operation. Next we see the memory representation of your linked list. So this is a sample memory representation. So here we have two parts. The first part is storing the data and the next part is storing the address of next node's memory address location. So initial value is at 1000's memory address location. So 1000 will be your start. So start will be pointing to the address of first node's memory address location. There you have the value as 10 and the next part is having the address of next node's memory address location. So the next node is at the memory address location 1003. So 1003 at the next location you have the value 20. So next address is at 1005. So from 1003 you have a link to 1005. Here you have a value 30. Next address is at 1006. So from here you have a link to the next node. So that is 1006. So here you have the value 40. The next node address is at 1008. So from here you have the value at 1008 memory address location. So this next part is having the value null. That means that this is the end of your linked list. So this can be represented as a linked list. So first node contains the value 10 which is at memory address location 1001. The next node is at 1003 where the value 20 is stored. So this takes the value 1003. At 1003 the data part is having the value 20 and the next part is having the value 1005. So here you will have 1005 and the next node value will be at 1005. So at 1005 you have the address as a value as 30 and the next value will be at 1006. So from here we have the node to 1006. So at 1006 we have the value as 40 and the next node will be at 1008 memory address location. At 1008 we have the value 60 and the next part is going to store the value null because this marks the end of your linked list. So the start pointer will be having the address of first node's memory address location. So the address of first node memory address location is 1001. So this is the sample memory address representation of a simple linked list. Now we see the first operation of your singly linked list, insertion in singly linked list. So insertion in singly linked list will be having two cases. Node inserted to the empty list, that means there is no node actually present. So whatever node you are inserting is the first node to be inserted. So initially you will have the start value to be null. The second case is a node is inserted to the existing linked list. So actually you have a linked list. In that linked list we are going to create a new node and you are going to insert it at the beginning of your linked list. So let me write the code simultaneously. So void I am creating a function for insert beginning. So since I am going to insert a new node, I have to create a new node based on the structure definition. So struct node pointer new node. So new node we have to allocate the memory from the free available spaces. So for this new node, using the malloc function, I am going to assign the memory space for this new node. Struct node star, I am using the malloc function. So using the structure definition and the malloc function, I have created a new node. So this new node has to be inserted. So first case we'll see, we are going to insert this new node to the empty list. So initially your start will be having the value as null. So here I am creating the new node. So this will be created at whichever free available space is there. So there the new node will be created. So let me take the address of this new node to be 1060. So the next thing is we have to get the data from the user, and the next part should be made as null. So using the scanf statement, I am getting the value for the data. So scanf %d ampersand new node of data. So from the user you can get any value. So let me take the value to be 14. So I have got it from the user. The next part I have to make it as null. So I am assigning new node of next is equal to null. So this part will be equal to null. So the next step is we have to connect this new node with the start value. So since the start is the first, we don't have any other node, the start will be pointing to null. So if you want to connect this new node to the start, this start should get the address of this new node. So you have to write the cases based on that. So if start is equal to null, you have to make the start to point to the new node. So you have to write start is equal to new node. So if you write like this, start is equal to new node, the start will get the address of new node. So here you will have the address of new node and you will have a link from the start to new node. So this is the first case where the start is equal to null. So the second case is the node is inserted to the existing list. So already we have a linked list. So in this linked list we are going to create a new node and we are going to insert it at the beginning of your linked list. So this is the actual linked list before insertion. So this will have the start will have the address of first node's memory address location. So if I insert a new node here, this node's address should be your start value. So I'm writing it in the else part. So I'm creating a new node here. So as per the problem, the data part will be having the null, 14, and the next part will be having the value null. So now we have to change the address of your start as well as the new nodes of next should have the address of this next node, that is 1005. So this 1005 is nothing but it is pointed by the value start. So you can write it as new node of next is equal to start. So if you write new node of next is equal to start, so the new node of next is the start value is 1005. So the new node of next will get the address as 1005. So now this node and this node is being connected. Now we have to change the address of your start also. The start should get the address of your new node. So you have to write like start is equal to new node. So this is the end of your singly linked list. So the start will get the address of new node. So 1060 is the new node's address. So here you will have the address as 1060. So the new node is inserted at the beginning of your linked list. So the next operation we are going to see is insertion at the end of your singly linked list. So here also you will be having two cases. The node is inserted at the empty list and the node is inserted to the existing list. So I'll write the code simultaneously. So insert end is the name of my function. So for creating a new node, I am writing a structure definition. So as usual, so we have to create a new node. So using the malloc function and the structure definition, I have to create the new node. So new node is equal to struct node pointer malloc size of struct node pointer. So I have created a new node. A new node will be created at some memory address location. So next we have to get the data part and we have to assign the next part to be null. So using a scanf statement, I am getting the data part from the user, new node of data, and then I am assigning the new node of next is equal to null. So here I am getting the data from the user and the next part I am assigning to be null. So we have created a new node. So this node has to be inserted either if you are having an empty list, it has to be the first node. If you are having an existing list, the new node that is created should be added to the end of your linked list. So we will be having two cases. So if start is equal to null, then it denotes that there is no node in your linked list. So the actual node, whatever the new node we have created, is the only link we are going to insert. So just change the address or value of your null. So this start will be having null. So this null should be changed with the address of your new node. So if start is equal to null, we have to assign start is equal to new node. So this null will get the address of new node. So you'll have a link from the start to the new node. So this is the first case, and the next case is you already have a linked list, and in this linked list we are going to insert a new node at the end of your linked list. So your new node will be created at the end of your linked list. So new node's address is 1050. It is having the data part 50 and the next part as null. So this new node has to be inserted to the already existing linked list. So the already existing linked list last node's next pointer will be having the value as null. So if you want to connect this existing linked list with a new node, we have to change the address of the last node's next value. So this should get the address of new node. So if you change the address of this node's next pointer, then the two nodes will be linked together. But directly we cannot jump to this last node. As in arrays, we don't have any index value here. So we cannot directly jump to the last node. So here you will be having a pointer variable. So that pointer variable will traverse from the first node till it reaches the last node. So I am creating a pointer variable here for traversing from the first node. So initially I am making the pointer variable to point to the first node. So I am placing the pointer variable to point to start. So this pointer variable should traverse until the pointer of next points to null value. So I am writing a while condition while pointer of next not equal to null. This pointer should move from the first node to the next node. Pointer is equal to pointer of next. So let us check. So pointer of next is having the value 1020, but it is not pointing to null. So if it is not pointing to null, pointer of next is not equal to null, we have to move our pointer to point to next value. So we are moving a pointer to point to next value. So this pointer variable will be pointing to the next node. So again check the condition. Pointer of next is equal to null. Here the value of your next is null. So we have to stop it here. So pointer has reached the last node. So after moving to the last node, we have to make the pointer of next to point to new node. So we can write it as pointer of next is equal to new node. So the pointer of next will get the address of new node 1050. So this node and this node will be linked together. So this marks the end of your linked list. So now the new node is inserted to the end of your linked list. The next operation is deletion in singly linked list. So deletion can be either done at the beginning of your linked list or at the specified position or at the end of your linked list. So here we are going to see how we are going to delete an element or the node from the beginning of your linked list. So it will be having three cases. The first case is empty list. There is no node in your linked list. So your start will be equal to null. The second case is the list contains only one node in your linked list. So one node in your linked list, that node is to be deleted. The third case is the list contains more than one node. So let me draw So the case one is empty list. So empty list denotes that there is no node in your linked list. Your start will be pointing to none. And the next is case 2. It contains only one node. So you will be having a start and you will be having only one node. So this node will be at some memory address location, will be having some value, and the start pointer will be storing the address of the first node. So this is the representation of the list contains a single node, then the list contains more than one node. So this is the representation of a list contains more than one node. So from this linked list, we are going to delete the first node. So let me write the code simultaneously. So void delete beginning is the name of my function. So in order to delete a node, I should have a pointer variable to point to which node I have to delete. So I am using a pointer variable for the struct node. I am creating a pointer variable called ptr. So we have to write all the three cases. So initially, if start is equal to null. So this is your first case. So if start is equal to null, there is no node to be deleted. So directly you can write the message as in the printf statement, no list to delete. So you can directly display a message and you can come out. The next case is else if start of next is equal to null. So it denotes that the start is having the address 1010. So this is the first node, this is your start node. This start of next is equal to null. So if you delete this node, then you have to make the start node to point to null because this node is deleted. So after deleting this node, there will be no node in your linked list. So this start should point to null value. So we have to write, we have to make a pointer variable to point to the first node, and then we have to make the start to null. So I am having a pointer to point to start. So pointer is equal to start. Then I am making start is equal to null. So I'll have a pointer here. A variable pointer will be pointed to the first node, and then I am making the start to point to null. So this link will be deleted since the start has become null. So next part is, this is already the link has been deleted, but this node has to be freed up so that it can be used by some other who are in need. So this has to be freed up. So for freeing, I can write free ptr. So if I write free ptr, this node will be deleted and it will be added to the free list. So the next case is, if you already have a linked list and in that linked list I am going to delete the first node. So this is the first node. So I am going to delete this first node from the linked list. So I have to make the pointer to point to the first node. So only I can make this pointer, I can delete this pointer and then I have to make the start to point to the next node. So first step is I have to make the start pointer to point to the next node's memory address location. So I have to write like, so first initially pointer is equal to start. So I am fixing a pointer variable to point to the first node. Then I have to travel from the pointer to the first node. The next operation in deletion is deletion in the singly linked list at the end of your linked list. So here also you will be having three cases. The first case is we are going to delete an element which is having an empty list. Case 2 is list contains only one node, and the case 3 is list contains more than one node. So for an empty list, the start will be pointing to null. So there is no node in your linked list, so we cannot directly delete any node from the linked list. The next is we will have only one node. You have only one node in your linked list, but that node we are going to delete from the list. And the next is we are having more than one node. And we are going to delete the last node from the linked list. So let me write the code for deletion at the end of your linked list. So void delete n is the name of my function. So initially, since I have to delete the node, I should have a pointer variable. So using the pointer variable only I can delete. So I am creating a pointer variable for the struct node. So ptr is the pointer variable. So we can write the cases one by one. So first case is if start is equal to null. So if start is equal to null, it denotes that there is no node in your linked list. We cannot delete any node from your linked list. So directly we can display the message printf no node. So this is your first case, and the second case is you have only one node in your linked list. So how you know that you have only one node is this node, the start of next will be pointing to null. So start of next pointing to null means only one node is there. So we can write it as start of next is equal to null. So if start of next is equal to null, then first we have to make a pointer variable to point to the first node. So ptr is equal to start. So I'm having a pointer variable to point to the first node. Then I have to make start of next is equal to null. So the start should be equal to null. Start is equal to null. So if I do so, this value will be equal to null. So this connection will be deleted. Since we have marked the start to be null, this link will be cut down. So next we have to make this pointer to join to the free memory list. So we have to write free ptr. So this is how we can delete the element if you are having only one node in your linked list. So this node will be deleted. So the next case is, so I'm writing the else part. You already have a linked list, and in this linked list we are going to delete the last node from the linked list. So this node has to be deleted. So we need a pointer. So where the address has to be changed is this node's previous node. This previous node next part should be equal to null. So if you make the previous node's next part null, then this node will be deleted from your linked list. But in order to in order to make this node's next part to be null, we should have a pointer variable to point to this node also. This node has to be deleted, so we need a pointer variable here as well, and this node's next pointer should be deleted, so we need a pointer variable here also. Since this is a singly linked list, we cannot directly use a pointer variable to point to the previous node. If it is a doubly linked list, we will be having a previous pointer also. So using one pointer variable, you can directly delete the previous node's next pointer. But here it is a singly linked list, so in one way only we can traverse. So we can use two pointer variable to delete the last node as well, and to delete the next node of the previous node. So we have another pointer variable called pre-pointer. So this pre-pointer has to travel with the pointer, so it has to point to the previous node. If the pointer is pointing to the second node, pre-pointer has to point to the first node. So let me write the while statement. So while the PTR has to move until the last node. So the last node will be addressed with the last node of next will be equal to null. So PTR of next not equal to null. Until then we have to make the pointer to point to the next node. So before that we have to make the pointer to point to start. So initially your pointer will be at this place. Then we have to make the pointer to point to the next node. So when pointer is here, we have to check the condition, and then we have to make the pre-pointer also to point to pointer. So pre-pointer is equal to PTR. So we have another pointer variable called pre-pointer. So pre-pointer will also be pointing to the first node, and pointer is equal to pointer of next. So pointer of next is not equal to null. So I am fixing pre-pointer to point to PTR, and then I am making the pointer to point to pointer of next. Pointer of next is 1020. So here we will have the pointer variable. Okay. So again check the condition. Pointer of next is equal to 1030. It is not equal to null. So we have to make the pre-pointer to point to PTR. So pre-pointer has to point to PTR. And the PTR has to move to PTR of next. So PTR of next is 1030. So this PTR will be moved to 1030. So again check the condition. PTR of next is equal to null. Here the condition is PTR of next is not equal to null, but here PTR of next is equal to null. So this loop will not be executed. So we have a pointer. The last node we have pointer variable, and for the previous node we have pre-pointer variable. So now we have to change the pre-pointer of next to null. So pre-pointer of next is equal to null. So this address will be changed to null, and this connection will be removed. So after we make the pre-pointer of next to null, we have to free the pointer variable. So this link will be deleted, and this node will be deleted from your linked list. So this is the end of the deletion in the singly linked list at the end of your linked list. Then I have to make the start to point to start of next. So this is your start. Start of next is nothing but 1020. So this start has to be changed with the address of start of next. So I have to write start is equal to start of next. So this start will get the address of the start of next, that is 1020. So this link and this link will be deleted, and you will have a link from the start node to the next node. So this link will be deleted. So after this, so we have already removed this first node, but since we are removing, it will not be added to the free list. We have to make this node to add to the free list. So we have to write free ptr. So now the node will be added to the free list. So these are the three cases for deletion at the beginning of your linked list.